Because you got to break down a lot of stuff in digestion.
Would a diluting an enzyme lower its effect?
Yes. And I know in the stomach.
That's a good, yeah, go for it.
Well, no, I was going to say in the stomach when you have like carbs and proteins and some of they cancel each other out a lot of the times, the enzymes.
Mhm.
And yes, those everything down.
Well, and that's actually a very good point when we talk about drinking water. I'm talking about water. When we eat, it's the one time we shouldn't necessarily drink water. We should just kind of eat and then, well, immediately we'll have an espresso. So digest, help to digest. Sometimes here I get that too. But yeah, that's the only time you don't want to drink too much water. Because you dilute the enzyme that digests the food. Interesting, huh?
So when they say they recommend for you to drink a tall glass of water before eating, really you shouldn't.
I don't think so. Who told me? I know the information is weird. Huh? Well, the reason why that is because you fill yourself before you eat.
I think they say 20 minutes.
They say 20
It's
minutes?
like, okay, and then you won't kind of screw up digestion. I think I read that.
Yeah, no, I mean, I know it's a confusing thing.
Yeah, like.
But when I talk to my,
right, would not be good.
I talk to my needle guy, my acupuncturist, that's his philosophy, their philosophy in that world, and I honor that world heavily because it's a very old traditional medicine thing, which we are a little bit behind on that sort of stuff. And then I also base that on a lot of naturopathic work. And then of course the other thing we do is do not drink water cold. It's really not helping the digestion. Just room temperature. Before I came to America, I never got a cold glass of water when I sat down on the table. The ice was totally here. I didn't get that at first.
Explain why they never do your ice.
Huh?
Here, never get ice with the water.
Well, their freezers are small. Okay, so let's see, where are we at? Are we going further with this? Where was my part one finished?
That was it.
That was it? Well, look at that. That was easy. We're off the hook. Any questions to what we talked so far? Gee, that was easier than I thought. Can't believe it. Yes? Yes. Now I might confuse myself to figure out which slide that was. When I look at the different types of bonds, octet rule, two types of bonds. So the main two types we talk about is the ionic bond and the covalent bond. The ionic bond, and again, we talk about the electrons on the outer shell of an atom. Those are the only ones that interact. In an ionic bond, one atom gets the whole electron and one loses the whole electron. So actually, in a solution, we then have two molecules that separate away from each other, like put put salt in water that separates out. You can't see the salt crystals anymore. And it becomes one atom that is positive and one atom is negative. Because in one atom now, the nucleus is one more positive than the electron that was taken, so that becomes positive. So that would be sodium. That's positive. And the other one becomes negative because it's gained an electron, so it has one more negative charge compared to the nucleus. That would be chloride integers. We use sodium all the time in the body. We talk a lot about it. That's a positive. So that's the ionic bond. Then the covalent bond, instead of taking and transferring the whole electron, we just share it. We're nice. Hey, these damn jokes. That I want to make.
You have memory tricks for remembering.
No, we'll figure that out. We'll figure that out. So then we have, so we share. So here you see actually two electrons share, right? That would be a double bond. Two of them. They call it double. If only one electron shares, this is only one, that's a single bond.
So a covalent bond can be either single or double.
Or even triple. I haven't seen quadruple, but triple we can do. Like carbon and oxygen. No, look, there's a quadruple. Carbon dioxide is a good example for a single. I even love that. And carbon dioxide here, monoxide and carbon dioxide here, looks like it's quadruple. That's probably real strong to tear apart. The interesting thing though with the bubble, single and double bonds, for us that's good enough, single and double, is that if it's only one line, that molecule can rotate the way it wants because it's like one thing holding it. It's called one axis, right? It's like you can rotate it around one axis. If it's more than one, if it's double or more, it holds it in place stiff. It doesn't rotate. And that becomes important because in butter, they all rotate. In oil, they don't. They use more space. That's why they're oil. That way instead. That's the difference between, you can write down two, saturated and unsaturated fats. The difference between the two of them is the different bonds that those molecules have. So that's sort of a place where you see that in the life. And then I think the other question was also the polarity, right? As well. And the hydrogen. So we go that further, maybe, yeah. Now we can have some of these covalent bonds, they're sharing the electrons nice and equal. But, even in hand you got bullies. So some of them want more of one electron than the other, and so you get a charged one. Here, the oxygen is pulling the electron more towards itself than the hydrogen has. And so as the more negative is up here, this becomes more of a negative pole. Because the electron spends more time up there. Versus down here, that becomes a more positive because the electron's missing. And so then we use those, and we can take the water molecules and we put the more positively charged and with the more negatively charged in. And we can create another bond, very weak bond, that's the hydrogen bond. And then we use that, for example, in the double helix, which is one place, or within protein. Protein is all, a lot of proteins are globular. It's another shape question. It's all about shape now. And so the inside, making it three-dimensional, has a lot of hydrogen bonds that hold on to different parts of the structure. Oh, mnemonic? For what? Ionic? Well, it's not the stealing.
I just thought maybe you had like a silly one in your back pocket.
No, see, it came off. No, I don't. When it comes to things like this, I often learn best when I learn one really well and I know the other one is the other one. No, I'm serious. I know, it's hard. I mean, because a lot of these things you just kind of have to, you want to understand them, but you also just have to kind of then memorize them too, because of foreign names,
Yeah, they are.
I don't know if this is helpful, but I always think of ionized salt.
There you go.
You have like the salt is ionized, so it's an ionic bond, it makes the salt.
There you go.
And ions a charged particle.
I think it must
So if it's a charged particle, then
Yeah, or
it's a radical. It's, it jumps. That's what they've done, they've jumped.
You can think of sharing as carrying
there you go.
Thanks, guys. I think it's going to get to that skeleton. We're all going to have to come up with songs and stuff.
Well, Herb Monster's coming back to that. The leg bones connected to that. You remember that Monster show? Guitar? All right, any other questions? Good, we can have a test.
No. No.
So as you study for the test, which you should start a little bit,
Yeah.
or at least get the information in order for all that, right? I think I urge you to do a flashcard challenge. Well, if you've been to college, you have your own way and all that, then have to do it your way. But if you're having a hard time with this sort of information, I suggest you take these slides and you say, well, what in this slide is most important? And you take these weird foreign words, but you make it your own description as much as possible. Because then you process it in a way that it's your own language and it becomes becomes an understanding. Every word you don't understand, you want to look up. Don't just memorize the words you don't get. That doesn't mean you got to know all the words here, but all the ones on your card. And if it's in your own word, there's a connection. And then when you study the card, the flashcard, all you really try to do is remember what you've already felt, what the process you already understood. And so, I mean, I'm very kinesthetic and I'm ADD, so I gotta make it as real life as possible. So, you know, that's sort of what I did in pilot school. Because visualizing it is almost like touching the cards, the taking time to sit down and do that laborious process first is very, very helpful to remember it. And I have a whole video of that thing. I know it's probably boring, but
It's pretty interesting.
it was pretty interesting. Well, that's how I
Five
learned. You
boxes.
know,